Look up at the sky on a calm afternoon and you'll see one of nature's quiet miracles unfolding above you. Massive white clouds, some stretching for miles, weighing millions or even billions of kilograms, drift effortlessly overhead like floating islands. They glide slowly, changing shape, glowing gold at sunset, sometimes stacking into towering mountains that bring thunder and rain. And yet, despite their enormous weight, they don't fall from the sky. This raises a question that feels almost magical when you stop to think about it. Why do clouds float? How can something so heavy hang in the air, suspended above us, seemingly defying gravity? The answer lies not in magic, but in a delicate balance of physics, temperature, motion, and invisible forces that are constantly at work in the atmosphere. Let's explore, right here, on History of Simple Things. To understand why clouds float, we first need to understand what clouds actually are. Clouds are made of tiny water droplets, or ice crystals, formed when warm, moist air rises and cools. As air rises, the pressure around it decreases, causing it to expand and cool. Cooler air can't hold as much water vapor as warm air, so the excess vapor condenses into microscopic droplets or crystals. Each droplet is incredibly small, often just a few micrometers across, and so light that it falls through the air extremely slowly. Individually, these droplets weigh almost nothing, and even when trillions of them come together to form a cloud, they don't behave like a solid object. Instead, they remain spread out, suspended in a constantly moving ocean of air. One of the key reasons clouds float is air density. Warm air is less dense than cool air, which means it rises, while cooler, denser air sinks. When clouds form, they are often embedded within rising air currents called updrafts. These upward-moving currents help counteract gravity, continuously lifting the tiny droplets and keeping them aloft. Think of it like dust floating in a sunbeam indoors. The dust particles are heavier than air, yet they remain suspended because even slight air movements are enough to keep them from settling. In the atmosphere, rising air currents are far stronger and more persistent, especially on warm days when the sun heats the ground and causes air to rise vigorously. Another important factor is the size and fall speed of cloud droplets. Gravity is always pulling on them, but because the droplets are so small, air resistance, or drag, slows their fall to a crawl. A typical cloud droplet might fall only a few centimeters per second, which is incredibly slow on a planetary scale. At the same time, the air within a cloud is rarely still. Turbulence, convection, and gentle vertical motions constantly push droplets upward or sideways, effectively canceling out their slow descent. As long as the upward motion of the air matches or exceeds the droplet's fall speed, the cloud remains suspended in the sky. Clouds also float because the atmosphere itself is layered and dynamic. The air isn't uniform. It's made of layers with different temperatures, pressures, and moisture levels. Many clouds form at specific altitudes where conditions are just right for condensation. At these levels, the surrounding air can support the cloud much like water supports a floating object. While clouds aren't buoyant in the same way a boat is, there is still a balance between the cloud's weight and the forces exerted by the surrounding air. This balance allows clouds to persist for hours or even days, slowly drifting with the wind rather than plunging straight down to the ground. So if clouds are constantly being pulled down by gravity, why do they sometimes fall as rain? The answer lies in growth. Cloud droplets collide with each other, merging into larger droplets over time. In colder clouds, ice crystals grow by stealing moisture from surrounding droplets, becoming heavier and heavier. Eventually, these droplets or ice particles become large enough that air resistance and upward currents can no longer support them. When that happens, gravity finally wins, and the droplets fall as rain, snow, sleet, or hail. In other words, clouds don't suddenly stop floating. Their particles simply grow too heavy to remain suspended. It's also worth noting that not all clouds float in the same way. High, wispy cirrus clouds are made mostly of ice crystals and form at extreme altitudes where the air is thin and cold. These clouds rely more on slow fall speeds and broad atmospheric motions to stay aloft. Low clouds like stratus clouds hover closer to the ground, often supported by gentle uplift over wide areas. Towering cumulonimbus clouds, on the other hand, are powered by powerful updrafts that can lift droplets and ice particles several kilometers into the sky. Inside these storm clouds, air can rise faster than 100 kilometers per hour, strong enough to keep even hailstones suspended for long periods. In the end, clouds float not because they are light, but because the atmosphere is active, layered, and constantly moving. Their tiny droplets fall slowly, rising air keeps them lifted, and air resistance gently holds them in place. It's a delicate dance between gravity and motion, one that plays out silently above us every day. Clouds float because tiny droplets, rising air, and constant motion balance gravity, an invisible dance of physics that keeps massive skies suspended above us every single day. The next time you look up and see clouds drifting across the sky, remember that you're witnessing an ongoing balance of forces, an invisible struggle that allows these massive formations to float gracefully overhead, reminding us that even the heaviest things can seem weightless under the right conditions. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.